over time, over years of reading Karl Popper, I collected a series of problems, specifically around the concept of refutation, that bothered me, that I thought, this can't be right, what I'm reading in Popper. And something happened. It was a conversation with Danny Frederick. I'll talk about it as part of the presentation, where he explained to me what Popper really meant. And it turns out Popper uses some terms idiosyncratically. So what I thought he was saying wasn't what he was saying. And once I understood what he was really saying, it clarified a lot. And I started to realize, now that I knew what to look for, I started to realize a lot of these problems I've been collecting, they're resolvable. And they've actually got pretty good answers. So I'm going to go through first the problems of refutation. Then I'm going to talk about Popper without refutation. And then if we have time, I will move on to some of the other things I've discovered, including, for instance, what's the demarcation that Popper came up with? Most people say it's between science and non-science. I actually am no longer convinced that's the best way to define it. And I feel like there's a number of clarifications you can make to Popper by understanding his special use of language and replacing it with more common terms, and it starts to make more sense. So let me take you through first the problems that I'd come up with. So I had a series of problems I had collected. So the first one was this idea that anomalous observations, they don't actually refute anything. Now, this comes from Kuhn. Thomas Kuhn is a famous historian of science / epistemologist who is at odds with Popper. And he, in his book, The Structure of Scientific Revolutions, which, by the way, I highly recommend. Popperians should not be afraid of Thomas Kuhn. They should, I think, the vast majority of his book, they will sign off on really easily. But Thomas Kuhn, in his book, The Structure of Scientific Revolution, he says, nevertheless, anomalous experiences may not be identified with falsifying ones. Indeed, I doubt that the latter exist. If any and every failure to fit were grounds for theory rejection, all theories ought to be rejected at all times. This is really a very valid statement. And in fact, it's been formalized as the Duhem-Quine Thesis. It says it's that all empirical hypotheses require one or more background assumptions. Because that's true, when you have an anomalous observation, something that doesn't match what you expected, so it doesn't match prediction, there's no way to know if the problem is with the theory or with something in your background knowledge. In fact, it may even just be something tacit or assumed in your background knowledge that you didn't even realize you were assuming. Because of this, Kuhn's statement is actually correct, that anomalous observations do not refute a theory and never can refute a theory. Given this, is this a problem for Popper? Well, some people think it is. I'm going to argue that it isn't, but let's put it out there as a legitimate problem that we want to see an answer to. Now, the next one was this idea of tentative refutation versus tentative support. So typically people, when they talk about refutation versus verification, or sometimes support, but let's go with the word verification for the moment. They talk about how there's an asymmetry between refutation and verification. And the asymmetry is described in various ways. Unfortunately, a lot of the ways people describe it is not correct. And Popper's actual statement about what the asymmetry is, I was surprised when I actually looked it up and read it for myself, because it was not what I was expecting. So let me take this quote from David Deutsch from The Logic of Experimental Test, which is probably one of the best papers ever written on scientific epistemology. Although it has a statement here that I'm going to question a little. He says, the asymmetry between refutation, tentative, and support, non-existent, in scientific methodology is better understood in this way, by regarding theories as explanations than through Popper's own argument from the logic of predictions, appealing to what has been called the arrow of modus ponens. Scientific theories are only approximately modeled as propositions, but they are precisely explanations. So the key thing here is the first statement, that the asymmetry between refutation and support is that refutation is tentative, it's never absolute, but support is non-existent. I think a lot of people would read that statement and they'd say that just isn't true. When Eddington went out and he did his expedition to test general relativity during an eclipse, and he found that the observations matched Einstein's predictions rather than Newton's, in what sense was that not support for general relativity? And that would be a completely valid question that deserves a completely valid, strong answer. Now, you might say, well, it didn't support general relativity, it refuted Newton instead. But if that's true, then how is that different than just saying it supported general relativity? Because once you're in a theory-to-theory comparison and you're doing a crucial test, why not just think of the word support as meaning that your competitors got refuted, right? I mean, why is it we have such a strong statement against the idea of support or verification, when really it seems like within a theory-to-theory comparison, which is what we're doing with a crucial test, we might as well just call it support and be done, because that's what most people call it. So For that matter, there's a second problem here. So let's take the idea of the perihelion of Mercury. Let me explain what that is. It was found that the orbit of Mercury didn't match Newton's predictions. Now, this wasn't the first time something like this had happened. They had also found that Jupiter's orbit didn't match Newton's predictions. And in fact, as we'll talk about it in a little bit, that was what led to the discovery of the planet Uranus. Is they saw that Jupiter wasn't matching the orbit it was supposed to. They said, okay, how much is it off by? And then they calculated that must mean there's a gravitational body we don't know about, a planet we haven't discovered yet. And then they went out and they looked for it where it should be based on theory, and they found.
Oh, and there it was.
Planets. Yes. Okay. So the exact same thing happened with Mercury. Mercury's orbit was off, and they said, well, there must be a planet we don't know about. So that they even named the planet Vulcan, by the way. They were convinced there was a planet Vulcan. They went out and they looked for it, and they didn't find it. Nobody really knew what to make of that. But it was not perceived as a refutation of Newton's theory. And it was just perceived as, well, there's something we just don't know about. There's like a gravitational body that we're missing somehow, is what they believed. Now, there was also something called the Michelson-Morley experiment. I hope I'm pronouncing that right. What they found was that when the Earth is traveling towards the sun, so you think about an orbit going around the sun, at some points you're going kind of further away from the sun, and some points you're coming closer towards the sun. So they had this idea that they should be able to measure the speed of light as being faster when they're going towards the sun and slower when they're going away from the sun. So they tried that, and what they found is that the speed of light was exactly the same no matter whether you were headed towards the source of the light or away from the source of the light. As those of us, since we live in the future and we have general relativity, that's the right answer, right? Because light's the maximum speed. That's not true under Newton, as far as anyone understood at the time. The perihelion of Mercury was an anomalous observation, but then again, so was the orbit of Jupiter being off. That was an anomalous observation also. And the fact that light didn't change speed, whether you were heading towards the source of light or away from the source of light, that's an anomalous observation. Did that cause us to, refute Newton? No. Nobody considered either of these to be serious problems for Newton other than Einstein. So did these refute Newton? Well, they didn't. There was certainly no perception that they refuted Newton. And if they did refute Newton, then why doesn't the orbit of Jupiter being off refute Newton? In which case we know it didn't. In that case, it was just that we missed a planet. Under what circumstances can we actually say an anomalous observation refutes a theory? It's not at all obvious. In fact, or rather, it is kind of obvious. It doesn't. Anomalous observations do not refute theories on their own. That's really the honest truth because of the Duhem-Quine Thesis. If these can't refute a theory, even if, because of the Duhem-Quine Thesis, then in what sense was the Eddington? So we have these observations that ultimately Einstein's going to explain. Perihelion of Mercury and the Michelson-Morley experiment, they're going to eventually be explained by Einstein's theory. And we're going to find out that really you have to know about general relativity to explain these anomalous observations. Okay, nobody knows that at the time. Nobody cares. It's not even considered a serious problem. Einstein comes along, he makes his theory. Now, in theory, he now can explain these. Did that cause everyone to say, Einstein can explain the perihelion of Mercury and the Morley experiment? No, didn't change anybody's minds. Nor should it, because at that point, it would just be an ad hoc explanation. It would be an explanation that was made up to explain specific problems. And generally, and Popper says we should never count such an explanation until it's testable. What really convinced people was the Eddington expedition. They went out, they had this observation that no one had ever thought to look for before that seemed weird, that the stars around an eclipse would move because the sun has a gravitational body that's causing the light to bend. It's so far outside of our experience or anything we would have guessed. They check it, it's true, and they come away feeling like general relativity's been supported by this experiment. And I would say it has. Okay, it has been supported by this experiment. And when Popperians insist that there's no such thing as support, I think they're right, but only if you understand the word support in a very narrow, idiosyncratic sort of way. And I don't think most people look at it that way. So I think they're doing themselves a disservice by insisting that there's no such thing as support. Okay, so the absolute verification fallacy. I need to talk about this. So when I've asked people about this, when I've said before, okay, typically we're looking for crucial experiments that are inside of a theory-to-theory comparison, then why can't we just say that an observation, the crucial experiment came out supporting one of the two theories, rather than insisting that we say we refuted one of the two theories. Now, I've asked this question of numerous Popperians, okay? And the answer I typically get back is that there's an asymmetry between refutation and verification, because verification is impossible. You can't verify anything because the words verification imply certainty, and nothing is certain. Whereas the words refutation, for some reason, don't imply certainty. I've always asked people, why don't the words refutation imply certainty? It just doesn't, is the answer I get back. And why does verification have to imply certainty? The absolute verification fallacy is the idea that the asymmetry between refutation and verification is because the word verification always means verified with certainty, whereas the word refutation always means refuted tentatively. Since one can never be certain, verification is impossible, but refutation is possible. Now, let me emphasize, this really is dumb. Okay, if this is truly the source of asymmetry that Popper intended, which by the way, it's not, but if it was, then Popper's wrong. Okay, because this is clearly just a fallacy. And then here's what makes it worse. It's the fact that according to Popper, the word certainty doesn't imply certainty. So this is a quote from Popper, from Objective Knowledge, page 78. There is a common sense notion of certainty, which means briefly, certain enough for practical purposes. When I look at my watch, which is very reliable, and it shows me that it is 8 o'clock, and I hear that it ticks, indication the watch has not stopped, then I am reasonably certain, or certain for all practical purposes, that it is close to 8 o'clock. Okay, so Popper understood this idea that even the word certain doesn't imply certainty. So there's no way he thought verification implied certainty. So there's something wrong with the absolute verification fallacy. It's a misunderstanding of Popper. For our purposes then, we're going to look at this idea of single theory versus theory-to-theory comparison. If you have a single theory and you don't have an alternative theory, then really refutations are impossible and verifications are impossible. They're both impossible. If you're within a theory-to-theory comparison, then refutations are possible, but then again, so is support, or maybe verification. I'll challenge that a little bit. Verification and support aren't really the same thing, because all you're really saying is that we're verifying one's more accurate than the other, or we're supporting it because one passed the test and one didn't. When I put it in this way, this really seems like it calls into question at least a certain common understanding of Popper's asymmetry, which in fact is actually a misunderstanding of Popper's point. The other one is this idea of corroboration and support. So Popper's had this concept of corroboration, which is really just identical to the concept of support. And in fact, Popper uses it as a synonym for the word support. So here's a quote from Popper from The Logic of Scientific Discovery, page 10. It should be noted that a positive decision in a test can only temporarily support the theory. For subsequent negative decisions in future tests may always overthrow it. So long as the theory withstands detailed and severe tests, we may say that it is corroborated. So here, Popper's clearly using the word support and corroborated as synonyms. Corroboration is a kind of support. Furthermore, Popper believed in the idea of corroboration as a matter of degrees, which may surprise some people, but here's a quote from Popper to prove it. This is Logic of Scientific Discovery, page 248. Instead of discussing the probability of a hypothesis, we should try to assess with what tests, what trials it has withstood. That is, we should try to assess how far it has been able to prove its fitness to survive by standing up to tests. In brief, we should try to assess how far it has been corroborated. Clearly, he's talking about matter of degrees here. So the idea of, I'm going to get to this, the idea of strengthening a theory, many Popperians will tell you it's impossible, or supporting a theory, supporting it in degrees, they'll tell you it's impossible. I do not find that in Popper. Okay, Popper himself does not seem to have ever made such a claim. In fact, this idea of degrees of corroboration, that's actually what Popper calls it. He calls it degrees of corroboration. He originally called it degrees of confirmation. He dropped it because he was dealing with the Vienna Circle, which is a famous group of philosophers. To them, the word confirmation implied proving the theory true, right? Which Popper believed to be impossible. So when he found that they were misunderstanding the term, he switched to a different term that had a slightly different connotation. But if you go look up the word confirmation and the word corroboration, you will find that they are absolutely synonyms of each other, okay? Now, it's true that synonyms usually have slightly different connotations. And in this case, they do. The word confirmation means something stronger in most people's minds than the word corroboration. It means the same thing, but it means it in a stronger degree. And so Popper was probably right to get away from the word confirmation and to go with the word corroboration because it got people closer to the concept he was thinking. But in fact, it doesn't matter what we call it. Okay, we can call it support, corroboration, confirmation. We can call it verification. That maybe not the best word for it, but we could if we wanted to. And it would all mean the same thing. The concept of corroboration from Popper is an incredibly important part of his epistemology. His epistemology does not work without it because otherwise everything becomes ad hoc. Testing would be unnecessary. So we're missing something here. What is it that we're missing is what I'm asking. Now, the other thing is that there are certain theories that require verification. So one example would be Bigfoot exists. The theory that Bigfoot exists. How would you refute that theory? Well, you can't, right? What you do is you verify that theory. You go out and you find Bigfoot, and once you found him, you put him in the zoo somewhere. Now you have verified the theory that Bigfoot exists. You can't ever refute that theory. Now that's a silly example, but let me give you a more realistic one that's an actual scientific example. And this does come from Popper himself in Logic of Scientific Discovery. He takes the theory that the element with atomic number 72, which is hafnium, exists. That theory, how do you refute that theory? Well, strictly speaking, you don't, right? What you do is you go find the element with atomic number 72. And by finding it and by verifying its existence, you verify that theory. So what's going on here? Is this an example of where Popper is wrong, that science is about refutation and not verification? It's not. So, spoiler, I'm going to explain in a moment that people are just misunderstanding Popper on this. But it's important to realize that verification does play an important role inside of science, particularly in the case of tests. When you have a prediction, you don't refute the prediction, you verify the prediction. So there's something more going on here. And as I've read Popper more deeply, I've come to understand he's actually addressed all this. So these are pseudo problems. Let me emphasize that. And yet I do want to put it out there. This is a problem you need to be able to understand, right? And need to understand how Popper resolved it. Now, Penrose, based on that last one, comes up with a challenge for Popper. So Roger Penrose, famous scientist, he says in his book, Road to Reality, pages 1020 to 21, he says he's challenging the idea of Popper's falsification. And he says the theory of supersymmetry predicts superpartners for all the observed fundamental particles of nature. But none of these has so far been observed. The reason they have not, according to supersymmetry theorists, is that symmetry breaking mechanisms of an unknown nature cause the superpartners to be so massive that the energies needed to create them are still beyond the scope of present-day accelerators. With increased energy capabilities, the superpartners might be found, and a new landmark in the physical theory would thereby be achieved, with important implications for the future. But suppose that still no superpartners are actually found. Would this disprove supersymmetry? Not at all. It could, and probably would, be argued that there had simply been too much optimism about the smallness of the degree of symmetry breaking, and even higher energies would be needed to find the missing superpartners. So based on this, Penrose claims that he's now shown that Popper's falsification is incorrect. This can't be the boundary between science and non-science can't be falsification, because here we have something that's an important part of science, important part of physics, and yet it can only be verified. Very similar to my previous example, but this is a stronger real life example that is currently part of physics and currently is being dealt with, whereas we've discovered hafnium at this point. Okay, now, sometimes best theories exist without refuting the competition. So a man is murdered and his wife has a motive. The police are going to start their investigation with the wife because they know she has a motive, therefore making her the best theory as to who committed the murder compared to anyone else that they currently know about. So the theory that someone else committed the murder is not refuted, like at all, just because we happen to know the wife has a motive. Yet the police rightly investigate the wife, given that this is now their best explanation. How do we fit this example with Popper? Now, if you're a good Popperian, this one's probably easy for you. Okay, but let's put it out there as one of the things that we want to see get answered. A similar one would be a DNA test. Let's say that, so like a while back, there was this whole thing about Thomas Jefferson had a slave, did the children of that slave, were they Thomas Jeffersons? And they did these DNA tests. And then there was a bunch of controversy around that. They found that the markers from Thomas Jefferson's DNA were found in the descendants. So some people claim that proved that Thomas Jefferson had in fact mated with his slave. And so, okay, this impinges his character. And then other people who are very pro Thomas Jefferson tried to defend, and they said, well, actually, his brother lived in the same house or was around all the time. And he has, likely the same markers. And okay, so you get this big discussion around this conjecture and refutation process. So let's make up one that's a little bit simpler, but similar to that. Let's say that you have this DNA marker, and in the population, in the general population, it's only a 1 in 10,000 chance. But it just so happens that the famous person that you're wondering, Thomas Jefferson or whoever, has it, and so do the descendants of this woman who was the slave. We know, and for the sake of argument, let's assume that there's no brother around, there's no other people around that we know of that could have that marker. Just based on probabilities, absent any other information, it really does seem like the best explanation now is that this person is the father. Now, we don't know that for sure. We haven't really refuted the opposite thing. There may be somebody else that lived in that town, that lived in that house maybe even, that happened to have the marker, and we just don't know who it is, right? And we don't have a way of testing for it easily. Absent any other information, though, I think most people would say, yeah, our best explanation is that this person is the father. And I would agree. I think that is the best explanation, even though we never actually refuted the competing theory. Okay, now that I've gone through these problems, let's talk about the idea of Popper without refutation, which is really what led me down the path to getting answers to all these questions. So now David Deutsch, in The Logic of Experimental Tests, page 8, he says, in the absence of a good rival explanation, an explanatory theory cannot be refuted by experiment. At most, it can be made problematic. Okay, boom, right there. Thank you, David Deutsch. He's completely correct. If only one good explanation is known and an experimental result makes it problematic, that can motivate a research program to replace the explanation, or to replace some other theory. But so can a theoretical problem, a philosophical problem, a hunch, a wish, or anything. But in any case, the existence of a problem with a theory has little import besides, as I said, informing research programs, unless both the new and old explicanda are well explained by a rival theory. In that case, the problem becomes grounds for considering the problematic theory tentatively refuted. This is from page 10 of this paper. Okay, so Deutsch is saying that a refutation requires not just anomalous observation or any number of anomalous observations, but also requires a second explanation. Now, this is actually a good answer. Now, we're going to see there's a little bit of a problem with it. Although it's more of a linguistic problem, it's not conceptually a problem. Under the Deutsch understanding of the word refutation, you do not refute something with an anomalous observation or any number of anomalous observations. You do it with a combination of an anomalous observation or observations and a second explanation. And this is not a bad way to think of the word refutation. As we're going to see, it's not the way Popper thought of it, but it is not a bad way to think of it. For many years, because I was aware of the Duhem-Quine Thesis, actually before Deutsch even had written his paper, I came out and I said, we really have to see refutation as only happening in a theory-to-theory comparison. So I had come up on my own, based largely on reading Thomas Kuhn, by the way, not Popper, that you have to have a second theory to be able to refute a theory. But I was always really bothered by quotes from Popper, because Popper just does not seem to agree with this. So, for example, Popper says, insofar as scientific statements refer to the world of experience, they must be refutable. And insofar as they are irrefutable, they do not refer to the world of experience. Now, maybe that doesn't sound that bad to you, but if you really want to get technical, that is a false statement if we're looking at the word refutable in the Deutschian sense, okay? Because a refutation requires anomalous observations plus a second theory. To be able to say that Newton's theory wasn't a set of scientific statements until Einstein's theory came along is just not true. And this statement, if I'm trying to read it with the Deutschian version of refutation, it just does not make sense. Okay. Here's another one. Can the assumption of the truth of test statements justify either the claim that a universal theory is true or the claim that it is false? To this problem, my answer is positive. Yes. The assumption of the truth of test statements sometimes allows us to justify the claim that an explanatory universal theory is false. Again, no mention of the need for a second theory. How about this one? As to falsification, special rules must be introduced which will determine under what conditions a system is to be regarded as falsified. We say that a theory is falsified only if we have accepted basic statements which contradict it. Popper would never accept a single test. So a basic statement would be a test that has been repeated by multiple people amongst the community. So he's saying, yeah, basically, you can refute a theory with tests alone. That's what he's saying here. Okay, this is from Logic of Scientific Discovery, page 66. The other two were The Open Society and Its Enemies, volume 2, page 13, and Objective Knowledge, page 7. If a refutation really requires a second explanation, the above passages just have to be seen as not true. Okay, now I'm going to go on a limb here. I'm going to say what I've just explained is one of the main reasons why Popper did not catch on, is because when you read Popper, when you read the statements like the ones I just quoted from her above, they seem like they are obviously false, and that it's very easy to think of counterexamples to them. Certain aspects of them are actually quite popular amongst scientists, particularly the concept of falsification seems to have caught on quite strongly in science, although they understand it wrongly, which is unfortunate. But Popper got largely overlooked because of this problem. I'm going to make that claim. Maybe I'm wrong, but that is what I think. Now, I had a conversation with Danny Frederick, who is a well-known scholar of Popper. He said, a refutation is a combination of the theory plus the background knowledge. So yes, you can have a single observation that refutes a theory. In fact, a single observation that is anomalous refutes a theory, but by theory, we mean the whole theoretical system. The theory in question, Newton, plus the background knowledge, number of planets, whatever. It's that combination that gets refuted. When he explained that to me, I realized he's using the word refutation to mean what Deutsch means by the word problem. Okay. And it's kind of a decent way it's not like it's totally outside the bounds of how you might use the word refutation. Words in real life have multiple meanings, depending on context. And you can see how, if you're talking about the whole combination of theories, that a single observation really and truly always refutes the theoretical system. There's never a counterexample. If you don't buy that, try to give me a counterexample. But if this is what the word refutation means to Popper, then those statements that I was talking about from Popper before all now make sense. They are all correct statements now, so long as you understand he's talking about the full theoretical system, not the individual theory that we happen to care about. Okay. Mm-hmm. Now, how does this change the way you look at Popper? Okay, so Frederick uses the word refutation to mean a single observation or set of observations that cause a problem for a theory. And Deutsch calls that a problem. So then Deutsch refers to the moment where you have the rival theory and it explains the problem, you can now tentatively reject the previous theory. So that's what Deutsch calls refutation. That's what Danny calls rejection. Okay. First of all, this led to an interesting idea, which is the whole idea of Popper without refutation. You don't need the word refutation. We can actually say, we can call the first event a problem, and we can call the second event rejection. And we can get rid of the word refutation altogether. Now, why would I want to do this? Obviously, probably no one's going to want to do this because the word refutation is so strongly associated with Popper at this point culturally that it wouldn't make sense to get rid of the word refutation. But it was eye-opening to me to realize I didn't even need the word refutation, that the word refutation was causing a misunderstanding because we tend to think of the word refutation as being about the theory itself and not about the theoretical system, the theory plus the background knowledge. This is what's leading to people misunderstanding Popper. This is what's causing people to reject Popper wrongly. Okay. Now, did Popper really understand that it was the full theoretical system? Danny was very insistent this was the case. Turns out he is right. And here's a quote from Popper that comes from Realism and the Aim of Science, page 187. A more serious objection to my epistemology is closely connected to the problem of context and the fact that my criterion of demarcation applies to systems of theories rather than to statements out of context. This objection may be put as follows. No single hypothesis is falsifiable because every refutation of a conclusion may hit any single premise of the set of all premises used in deriving the refuted conclusion. The attribution of falsity to some particular hypothesis that belongs to the set of premises is therefore risky. Okay, notice that this is precisely what Danny Frederick was talking about. Okay, I mean, like almost word for word. You have to really have read Popper widely to put together a lot of these things because he doesn't necessarily explain it in each individual book, right? But this was very eye-opening for me. Now, let's compare this with the dictionary definition of refutation and falsification. Now, I just Googled these and it gives me a definition. Here's the definition for refutation: the action of proving a statement or theory to be wrong or false. Falsification: the action of falsifying information or a theory. Okay. This is how people normally think of these words, and it is not the way Popper intended it. That's why people read it in. That's why people, including myself, including Deutsch, including very intelligent people, read Popper and do not come away with the realization that when he's talking about a refutation, he's talking about the whole theoretical system, the theory plus the background knowledge. Popper then goes on from that previous quote to say, it's not really a problem. And he gives a very good answer as to why. The fact that you're actually refuting the combined system isn't a problem, because the next step is to conjecture which part of the system is wrong. That is a good way to think of refutation. That's not necessarily a bad way of defining it, but it is counter to the way people normally think of it. And that's why people misread Popper. And that's why Popper hasn't caught on as well as he should. To make matters worse, Popper often leaves you with the impression that it's just the theory itself that gets refuted. So Nathan Osseroff, who's another Popper scholar, in his paper addressing 3 popular philosophic myths about Karl Popper's demarcation criteria, he says, reading Popper's The Logic of Scientific Discovery would be sufficient for many people to arrive at the conclusion that falsifiability applies only to individual theories. So he gives quotes from Popper where he says, when you falsify a theory, he always says a theory, when he really means theoretical system. So Osseroff says, any use of the word theory in relation to Popper's falsifiability criteria should be understood as an elliptical expression for theoretical system. This is from page 10. The first one was from page 6 of that paper. So Popper has largely done himself a disservice. People are bound to misread Popper because of the way he's currently wording things. So here's my proposal. Now, I'm not suggesting we actually do this when we're talking amongst Popperians, but when we're talking to people who are outside, Popper's people who already know Popper well, I think the word refutation is a misleading term. I think what we really should call it is a counterexample. Okay. And verification is itself a misleading term. I think it should be called a positive example or a positive instance. Popper used the word criticism. So to Popper, a refutation is specifically a problem with an empirical theory. So a refutation is an actual observation statement, a basic statement from an experiment, okay, or an observation that exists, where he would use the word criticism for a more general problem. So a philosophical theory that has no empirical content can't have refutations because you can't do experiments on it. But it could have criticisms, problems with it that are criticisms. I think we should just use the word problem for all of those and use counterexample specifically for a test case, what Popper calls a refutation. If you change those things, then the word conjecture needs to change a little bit too. Popper would often speak of conjecture and refutation as a summary of his epistemology, which I'm now claiming is misleading. Instead, we should probably call it problems and conjectured solutions, which has the nice addition to it that Popper says we always start with problems. So even though we always start with problems, he still called it conjecture and refutation. It really should be problems and conjectured solutions. So if we rethink of Popper with just very small change of wording, I actually think Popper becomes a lot more understandable. So I haven't really solved the problems yet. And I want to go through and I want to demonstrate that now that I'm reading Popper correctly, it turns out all of these problems are really fairly easily solved. That there really are none of these are actual problems for Popper, that they were actually based on misunderstandings of reading Popper wrong. And it was a bit of a shock to me that I had been misreading Popper for years. I had been thinking he meant something by the word refutation and something by the word theory, and I was wrong. He actually meant something else. And while I haven't actually solved the problems yet, my guess is that you can start to make some guesses as to how this will pull the thread that unravels the mystery and shows how to deal with each of the problems I previously raised. So let's do a quick review here. So when Popper speaks of refutation, he really means a counterexample or a problem. But we're talking about a real theory. We're talking about some combination of the theory plus the background knowledge. you don't have a true refuting case if you mean the theory itself. You're really refuting the combination of all the theories that you are dependent upon. Theories about your instruments, assumptions about how many planets there are, everything in your background knowledge, some of which you may not have even explicitly thought of. It's just a tacit assumption that you're making. You're actually refuting that whole combination. Okay, therefore, it might be better to refer to them as problems or counterexamples. It can be thought of as a refutation of the combination of the theory plus the background knowledge. Okay. And it would be very common for there to be background knowledge that you have to carefully think about. It would probably be better not to call such problems a refutation at all, as the words carry too much baggage. This is one of the main sources of misunderstanding that exists about Popper that has kept his philosophy from catching on. Okay, here's the key thing though. Problems are objective. Okay, there's never a case where a problem isn't a problem. Now, again, let me make sure we're always talking about theory plus the background knowledge. The fact that Jupiter's orbit didn't match, that was a problem that had to be resolved. And it had to be resolved by adding an eighth planet, to the solar system. The fact that my instrument is off and I have to recalibrate it, that is a problem. And I have to change my theory by recalibrating my system. That changes that part of that theoretical system. There's never a case where a counterexample or a problem isn't an objective fact that you have to deal with. And this is why this matters, is because the fact that problems are objective is precisely why Popper's epistemology is correct and why progress is always possible. Because you always have something you can hang your hat on and say, okay, now I've got to deal with this problem. I can now conjecture how to deal with that problem. All right, so let's talk about now a bit more about Popper's epistemology, specifically the asymmetry. There's at least a common misunderstanding amongst lay Popperians like myself, at least. There's this misunderstanding that we call the absolute verification fallacy. It's the idea that when Popper talked about refutation, we refute theories, but we can't verify them or support them. That what he really meant was that refutation is always tentative, but verifications imply certainty, and certainty is impossible. Well, if that were really the case, if that were really what Popper meant, then all we would need to do is replace absolute certainty with tentative certainty. And suddenly we've restored the symmetry between refutation and verification. So that can't possibly be what Popper meant. Well, what did Popper mean? Well, he explains. I'm going to quote him here. He says, this asymmetry that he's referring to has a purely logical and also a methodological or heuristic aspect. As to its logical aspect, there can be no doubt that a unilaterally falsifiable universal statement is logically much stronger than the corresponding unilaterally verifiable existential statement. Remember, we talked last time about the fact that a universal statement can logically only be refuted and an existential statement can only be verified. For the following is a well-known logical rule. From universal statement pertaining to all things of a certain kind, or all elements of a certain kind, 1, all things have the property P we can derive for any individual thing A belonging to this kind of universe. 2, the thing A has property P. And from 2, in turn, we can derive 3. There exists a thing that has property P. Thus, 1 entails 2 and 3. 2 entails 3, but 3 does not entail either 1 or 2, and 2 does not entail 1. In other words, 1 is logically stronger than 2 and 3, and 2 is logically stronger than 3. And this is the source of the important asymmetry in the case of unilaterally falsifiable universal and unilaterally verifiable existential statements, and the situation is the same for more complex statements. This is from Logic of Scientific Discovery, page 184. Okay, so let me explain this kind of in plain English. So a universal statement would be like, there are no such thing as women. If I say there are no such thing as women, all right, if we're assuming that statement is true, that tells me the statement Cameo is a woman is false. Okay. In fact, it also tells me the statement that, Margaret Thatcher is a woman is false. It tells me all sorts of things. And this is what he's getting at, is that science is built on universal statements like this, constraints, things that say this cannot be true, or this is always true, or something along those lines. And because those are the statements that we are interested in science, it makes sense that those are only logically refutable. Okay, this is the asymmetry. Now, it's a logical asymmetry. It's got nothing to do with certainty or lack of certainty. Okay, that this does not even play a role in Popper's asymmetry. And this is what the absolute verification fallacy is misunderstood. This is also why he used the word refutation, because when you're dealing with logic, the correct term in English for how you show that a universal statement is false is called a refutation. This is Popper again. Owing to the logical power, universal statements may be important as explanatory hypotheses. They may explain, especially in conjunction with singular initial conditions, singular events or statements. Purely existential statements, on the other hand, in isolation or even in conjunction with singular statements, are usually too weak to explain anything. So this is why scientists are interested in universal hypotheses rather than isolated existential hypotheses. Notice that this is almost more like a convention. Popper's not really saying you're never going to be interested in a theory that has an existential statement. And this is a good nuance to understand, that he's talking about a certain convention. It's possible to word things in such a way to make Popper sound wrong, but then you're just misunderstanding his point. And I'll give an example of that in a second. This leads to this methodological or heuristic aspect of asymmetry, due to the difference between the critical or falsificationist attitude and the verificationist attitude. This is Logic of Scientific Discovery, page 184. And then he talks about how predictions are verified but not refuted. Verification plays this huge role in Popperian epistemology. It's just in terms of experiments. Testing via prediction is the main case where Popper's epistemology cares about verifications. This is because predictions take the form of singular statements, which are a form of existential statements and thus have to be verified, not refuted. So here's Popper again. Certain singular statements, which may be called predictions, are deduced from the theory being tested. If the singular conclusions turn out to be acceptable or verified, then the theory has, for the time being, passed its test. We have found no reason to discard it. Notice that Popper does not avoid the word verified when we're in this context. Okay. And for those who think I'm doing this wrong, I looked up in the index and it said existential statements can only be verified in the index. So Popper does not avoid the language of verification. He's just using it in a different context, specifically how we test things, how we test predictions. Okay. So to really understand this distinction now and to get this kind of driven home, what Popper was getting at, let's talk about his demarcation criteria. So now, famously, his demarcation is between science and non-science. I'm going to make the argument that this is really about the worst way he could have said it. He's right in the way he's thinking of the word science, but not in the way most people in the English language think of the word science.
Okay.
What he really means is that his demarcation is between empirical and non-empirical. That's what he really means. And in fact, here's a quote from Popper where he says it outright. The criterion of demarcation between empirical and non-empirical theories, I have called the criteria of falsifiability or the criterion of refutability. It does not imply that irrefutable theories are false, nor does it imply that they are meaningless. But it does imply that as long as we cannot describe what a possible refutation of a certain theory would be like, the theory may be regarded as laying outside the field of empirical science. So notice the first part of the quote, he doesn't even use the word science. He just says empirical and non-empirical theories. And then when he does mention the word science, he qualifies it as empirical science. To Popper, the word science meant the set of empirical theories. The goal of science is usually to make a theory testable. So the gold standard of science is that the theory is empirical. But when you're initially coming up with a theory, it's often not empirical. It takes you a while to figure out and refine that theory to the point that you can figure out tests for it. And sometimes it takes a long time. String theory still has no empirical consequences that we know.
Right.
Okay.
And sometimes we just might not have the technology yet to test the theory.
By the way, that's a good example of how you can't easily differentiate between the theory and the theoretical system it's attached to. Because a theory may be non-empirical for its current theoretical system, but as instruments change, that part of the theoretical system changes, and now that original theory that was non-empirical has now become empirical. There's no real distinct boundary between the theory proper and the rest of the theories that it relies on. So this is actually the answer to Penrose's problem, is that when he said Popper's wrong about refutability because there are theories in science that aren't refutable, but they're legitimate science, he's simply a misunderstanding that Popper was actually talking about empirical theories, in which case the two are in agreement. Let's go back to Penrose's example of supersymmetry. His argument was supersymmetry, and he also mentions string theory. are important parts of science, yet they cannot be refuted, ergo Popper was wrong. But if the boundary is empirical versus non-empirical, then actually Popper and Penrose are agreeing. Those are both non-empirical theories, period, end of story. So this is no longer a disagreement between them. It was just a misunderstanding on Penrose's part, in part because of the fact Popper chose to refer to it as the boundary between science and non-science. Even when he clarified empirical science, I think people just missed that clarification, right? It's so easy, but the word science just has a broader range of meanings. It's not always the set of theories that are empirical. Yes, string theory is a part of science. Yes, supersymmetry is a part of science. They're just not part of the empirical part of science.
Yeah.
Okay. So by insisting on the demarcation science versus non-science, we set up a war of words. And this is why I don't think we should do that anymore. Where really Penrose is always going to claim string theory and supersymmetry are a part of science. I've seen Popperians try to say, and non-Popperians too, people that agree with Popper but not necessarily Popperians, say, oh, string theory is not science. I've seen people say that. It's like fighting words. Like there's no point in saying that. Okay, now, I just said there's no one who can argue with you, but actually you could make one argument here. And I'm going to now clarify that argument. So Sean Karl, he gave and I put this out on Twitter for comment from people. He attacked Popper's theory, and he attacked it on exactly the grounds I just gave, that there are theories like string theory that in theory we can verify them, but we can't refute them. And then he said, but what if we actually do find one of these particles? What if, to use the Penrose example, I don't think this is the example he was using, but it's very similar. Let's say that we get bigger and bigger colliders, and then we actually find superpartners. Okay, wouldn't that then verify supersymmetry in some sense? I mean, obviously it can't in any absolute sense, because there may be some other theory that also predicts superpartners. So you can't verify it as completely correct. But wouldn't it give us some sort of support for the theory is what I'm trying to say. Yeah, of course it would. Okay. And this is what Sean Karl then used to say, this proves Popper is wrong. And he would go a step further. That was empirical, Sean Karl would say, because we actually did an experiment and we found it. Okay. Well, now it depends on what you mean by empirical. But let me make a case that that's not a great way to use the word empirical. I'm not going to deny that the word empirical could be stretched to include that case. So he says, I admit a system as empirical or scientific only if it is capable of being tested by experience. The key thing here that we're talking about is when Popper says testable by experience, he really means I can set up a program for test and get a definitive answer. So yes, I could build larger and larger colliders. And in theory, maybe I find superpartners at some point. And yes, in theory, that was a test in some sense of string theory or supersymmetry. But really, nobody is going to think that these are fair tests, because every single time you don't find something, you just wait for the next collider and then you see if it finds something. And if that doesn't, then you just wait for the next collider. There's no definitive answer ever until you actually find it. So it's not a definitive test. It's not a test in that sense. Popper, when he talks about a test, he means it in the normal scientific sense of, I'm going to do this test and it's going to distinguish between theories. That's what he means. He doesn't mean test in its looser sense of, who knows, maybe we'll find it by chance.
Okay.
And this is really what he means by empirical, is we can set up a program for tests, we can do this test, we can definitively decide, was this correct or not? And that will always be only on
universal and thus refutable theories.
And that's not normative. That's just a statement of fact as to how these things work logically. You always would have, if you're going to have a definitive test, then you have to have some sort of universal statement that says, okay, under these very specific spatio-temporal conditions, you will find this result. And if you don't, the theory's wrong. That's an empirical test in Popper's mind. So an existential theory that has no attached constraints like that can never have a program for test. It just can't. It's logically impossible for it to have it. So constraints by definition imply universal laws. And universal laws have to be refuted because that's the way logic works. Ergo, empirical equals logically refutable, done. Now, let's talk about how this gets a little weird. Okay, why he's right, but why it feels like he's wrong sometimes. Popper gives the example of the theory that the element with atomic number 72, which is hafnium, exists. When stated in that way, that is an existential statement, and it can only be verified. So Popper points out, though, that this theory was never actually verified until the theory had developed enough that there was reasonable constraints that helped us understand enough about the element 72 that we could reasonably go look for it. He says all attempts to find element 72 were in vain until Bohr succeeded in prediction several of its properties by deducing them from the theory. But Bohr's theory and those of his conclusions, which were relevant to this element, are far from being isolated, purely existential statements. They are universal statements. Logic of Scientific Discovery, page 49. So this creates this weird circumstance where we speak of a theory we use linguistically, we may speak of the theory that atomic number 72 exists. But what we really mean is something more complicated than that. We mean we're going to go find atomic number 72, and part of the theory are the following constraints, and therefore we should do this following test to find atomic number 72. Well, the part of the test we're doing, that's going to be a series of universal statements because they're constraints, because that's what universal statements and constraints are. They're the same thing. What you're really going to do is you're going to try to refute that part of the theory. That's what you're really going to do. And when you then do that, find element number 72, you're then going to announce to the world, we verified the theory that element number 72 hafnium exists. There's nothing wrong with that. And it's not counter to Popper. He's saying something very specific, which is, look, if you're going to try to test this theory, it has to have constraints. Those are universal. Those will have to be refutable. And that's how you're going to set up your test. And once you've done that, yes, then you can announce to the world, we verified atomic number 72 exists. Nothing wrong with that. That's not counter to his theory at that point. You've simply, if you think it is, you've simply misunderstood what he was actually saying. And in this case, though, what Popper would say is, look, even in that case, what was the alternative theory? Since this theory is being worded as an existential statement, even though it's not really, it's more complicated than that, its counter theory would be, there is no atomic number 72. When you found atomic number 72, you refuted that universal statement. So even in a case like this, you're really still always refuting things. And it's really the refutations that mattered. What mattered here was you killed the alternative theory through a refutation. Now, the reason why this is weird is because existential statements, when we word a theory that way, their competitor is basically just the inverse of it. The theory, atomic number 72 exists, its competitor is that it doesn't exist. That's just not true for most scientific theories. The theory, Newton's theory, its inverse is not Einstein's theory. Okay, this is something that David Deutsch always points out. So in the scientific realm, except when you happen to be wording things like an existential statement, the inverse of the theory is not its competitor. In the one case where we're wording the theory as an existential statement, which sometimes that is just the most convenient way to do it, so you should. In a certain sense, the theory you really care about is its inverse, that atomic number 72 does not exist, and you're refuting that. In other words, Popper's theory still works. There's never a case you're going to come up with where Popper's theory doesn't work. What you will come up with, though, is cases where it's much easier to word things as a verification. But those aren't refutations of Popper's theory. That's a linguistic misunderstanding of Popper's theory. Okay, are you with me on that? Do you follow what I'm saying here?
I do, yes.
Okay, so how does this tie to induction? Everything Popper talks about is all tied together. This is something that I think a lot of people miss, is they've got this idea of his epistemology, and they think it's distinct from the fact that he has this boundary condition on science, and I think that's distinct from how he solved the problem of induction, but they're all really all part of one program. So how does this all relate to induction? Okay, so what we need, if we're going to do science and make it empirical, keeping in mind that in Popper's mind, science equals empirical, is we need a way to learn about the world through observations. Now, David Deutsch would be the first to say that you can't learn about the world through observations. That's empiricism. It's not quite true. It's almost true. We do need a way to learn about the world through observations because we've got observations available to us. Empiricism, by the way, is really the idea that observations are infallible, which is not true. That's the part that's really false about it.
Okay.
So induction was this fictional form of logic that allowed you to flow from observation to general law. So I've seen 100 million white swans. I can now deduce that all swans are white. Now, obviously, that's just logically false because you can't make that assumption no matter how many white swans you see. So what is the relationship then between observation and general laws? This is really what Popper was trying to solve. So everything I just said, I'm going to say it again, but in a different way. The idea here is that no truth flows. If what you're trying to do is you're trying to demonstrate that all swans are white, no truth flows from the observation that you have a white swan to the rule, all swans are white. You cannot deduce anything that way, okay? But you can deduce that theory is wrong by having a non-white swan. And that is also an observation. So that's a case where we can deduce something about universal laws through an observation. And that's what science needs to do. So science needs a way to do that. Therefore, it has to be refutation. That was how he figured this out. So here is Popper's statement from page 19 of Logic of Scientific Discovery. Such an argument to the falsity of universal statements is the only strict deductive kind of inference that proceeds, as it were, in the inductive direction, that is, from singular to universal statements. This is the relationship between induction and how Popper addressed induction and the rest of his theory. Is he was trying to work out, how do I learn something about universal laws through an observation? Oh, I see, I can do it through refutation, through a logical refutation. So Popper's epistemology captures the only logically deductive way we can learn from observations. Okay, now, can you strengthen a theory? Many Popperians claim you cannot strengthen a theory. I think they're technically correct if you happen to understand the word strengthen in a certain peculiar way. I think that when understood as, can the theory become more sure? No, it can't. There is no way to make a theory more sure. But I would have to ask the question, when somebody says, I saw this observation and it strengthened this theory, what do they mean? Are they meaning this in the inductive sort of way? I don't think so. So Mark, he threw out the example on social media. He said, listen, what about Brownian motion? When we discovered Brownian motion, how can you say that didn't strengthen the theory that atoms really exist? Because at the time, there was the belief that atoms were actual physical things and the belief that they were just kind of instrumentalist numerical things that we use, but they didn't actually exist in real life. Okay. And, Mach was a super famous scientist that backed that idea. And he said to Andrew Crawshaw, how can you say that doesn't strengthen the theory? Well, they were talking past each other. What Andrew meant was nothing about that theory changes just because Brownian motion was found. What really changes is that its competitor is no longer viable. And it's now the last remaining theory. My point of view is that when Marx says it strengthens the theory, that's what he meant. And so trying to tell him you can't strengthen the theory when clearly you can, even though what we want to do is we don't want to tell Mark you can't strengthen the theory, which is what Andrew was saying. We want to tell Mark, yes, you can strengthen the theory, but what you mean in this case is that Brownian motion made Mach's version of atoms non-viable. So there was only one competitor left. There was only one theory left, that atoms were real things, that they physically existed. That's what we mean by strengthen a theory. I think there's one other thing we mean by strengthen a theory. I think you can also strengthen a theory by making it more testable. Now, this depends on what you mean by theory. But if I were to look at Darwin's original theory of evolution and then compare it to modern synthesis today, the way it ties in with DNA theory and just all the things we can do today, one could argue it's the same Darwinian theory, or one could argue that we've long since refuted Darwin's original theory and replaced it with something far better that still had the heart of Darwin at it. It depends on what you mean by theory. If we're going to be really kind of technical in the logical sense, which is what Popper was doing, then we have to understand that every time we improve a theory to make it more testable, even if that means we've improved the instruments that are attached as part of the theoretical system, that in a certain sense, we refuted the old theory and we now have a better one. Because of that, the idea of improving a theory by making it more testable is actually a special case of case number one, which is strengthening a theory means that you've killed off its competitors. However, because that feels different enough to most people, I'm not going to insist on that. So let's just say there are two ways to strengthen a theory. One is you kill its competitors, and the other is that you make your theory more precise so that it's more testable, which means it's more empirical. It has more empirical content. That these are the two senses in which you can strengthen a theory. I don't think any Popperian would argue with me that you can do those two things, that they're important. I think what they would argue with me is that they would tell me I shouldn't use the word strengthen to call those two things strengthening of a theory. I'm simply disagreeing with them. That's essentialism. They can choose what words they want. I can choose what words I want. I think mine are easier to understand, so I'm going to go with mine, especially when I'm talking to non-Popperians. Yes, you can strengthen the theory, but you must understand that what you're really doing is you're either increasing the empirical content of the theory or you're killing off its competitor. And I can give them an example. And I can always give them an example because it's always one of those two things. That's all strengthen would ever actually mean. Now, it may be that some people, when they say strengthen the theory, they are thinking in terms of inductivism or surety. They may be thinking, we've now proved, Brownian motion happened. We've now proven 100% that atomic theory is correct. Okay, no, if that's what they mean, then yeah, they're wrong. Okay. And maybe some of them do mean that. So it may be worth clarifying what they mean. Look, when you say strengthen a theory, do you mean this or do you mean that? I think strengthen the theory means that we've killed its competitor. Is that what you mean? I mean, we can talk to people. We don't have to jump down their throats over what word they used. Okay, so now with all this in mind, I'm now going to resolve all the problems and then we'll be done. Okay, so let's go through each of the problems. So Kuhn, nevertheless, anomalous experiences may not be identified with falsifying ones. Indeed, I doubt the later exist. If any and every failure to fit were grounds for theory rejection, all theories ought to be rejected at all times. So when he says anomalous experiences, he means counterexamples.
Right.
When he says falsifying ones, he means ones that target a specific theory, which as per Duhem-Quine, don't exist. In other words, he's just misunderstanding Popper's theory, because Popper's theory is actually about what you can do with anomalous observations, with counterexamples, right? What he's calling anomalous experiences is what Popper meant when he said refutations. If you understand Kuhn as meaning by refutation the theory itself, then he's actually right. But that isn't what Popper meant. So the two men are not actually disagreeing. They're actually saying the same thing. Tentative refutation versus tentative support. So Deutsch said the asymmetry between refutation, tentative, and support non-existent in scientific methodology is better understood in this way by regarding theories as explanations. First of all, Deutsch is using his terminology different than Popper's. To Deutsch, a refutation was a combination of an anomalous observation, a counterexample, plus a rival theory. So it's something that happens later in the process. Whereas to Popper, it was the original anomalous observation, but the theory that was being refuted was the entire theoretical system, the theory plus the background knowledge. That's the first thing you have to understand what Deutsch is saying here and how it differs from what Popper is saying. So now, Deutsch is also mistaken a little bit here. He says you cannot support a theory. Now, the way he's taking the word support, maybe that is true. He never clarifies what he means by support, but you can absolutely support a theory through corroboration. Okay. So yes, there is such a thing as support. And if someone were to read this statement, I think what I would suggest to them is Deutsch is correct, but only if you understand support as meaning prove a theory completely true. That is truly non-existent. And that's what I think he had in mind at the time. And you have to also understand that he's talking about related but different asymmetry, and that Popper's original asymmetry was actually a logical one. And that there's actually a little bit of a disagreement here between Deutsch and Popper over this. I won't get into the disagreement. I have a blog post where I talk about it, but Deutsch is taking this a somewhat different direction. He's not necessarily wrong, and there's not necessarily a disagreement at the conceptual level, but Deutsch is downplaying the logical aspects of Popper in this paper. And so now let me also point out that I think when he uses the word support, that maybe wasn't the best word. If he'd used the word verify, that would have been a better word. Support and verify aren't the same thing. You may think of them as the same, but they're not. And this is a weird thing for people to wrap their mind around, that we may use words like support and verify, but what we really mean, when we really get down to it, when we're looking at it at the logical level, we're really talking about refutations. And we're always talking about refutations. We're always talking about a competitor dying, even if the competitor is an improved version of itself versus a less improved version of itself. Okay, corroboration and support. Support. So I raised the issue that this is related to the Deutsch one. Really, Deutsch is just picking a bad word here, in my opinion. Corroboration is a kind of support. Support is always just tentative, though, as Popper says. It's always temporary until we think of a good refutation. We go out and we test our theories as best we can. We try to refute them. We may fail to. We call that corroboration. That plays an important role in Popper's epistemology. Okay, so you can't really say support plays no role in a Popper's epistemology. It's just not true. Now, what is it that it's doing? Now, this is where Bayesians make a big deal. They say, look, you're claiming as a Popperian that the epistemic status of a theory can't change. It can't strengthen. I just admitted that that's not true. but often Popperians claim that wrongly. Whereas we're saying it can. We're saying you can have positive evidence, you can have negative evidence. So our theory is better than yours. Okay, let's clarify this now. What's really going on? Okay, let's use an example of Sadia. She doesn't like the many worlds interpretation theory. She still will say it's the best current theory we have, but she's trying to favor other more speculative theories in science based on certain problems that she perceived. So right now, we already have a best theory of quantum mechanics, and it's many worlds. So in a certain sense, those two theories are one and the same. But Sadia's point's not wrong either. There are problems, and it may be that one of those days, those problems force us to come up with a theory that does away with the many worlds aspect of quantum physics. Okay, that's not a completely logical impossibility. Now, let's say, though, that we corroborate the theory in the following way. Let's say we invent a time machine, and when you do, it works exactly the way quantum mechanics claims it should, where you go back into a moment of time, but at that moment, that reality branches off from the original reality. And so you go back in time, you kill your grandfather. So you're never born in that reality, but it doesn't cause you to disappear like Back to the Future, because you existed in a timeline where your grandfather continues to exist. This is the many worlds version. So let's say we do this. Let's say we do an actual experiment. Now, no one in their right mind would not see this as strengthening the theory of many worlds quantum physics.
I agree.
What do we mean in this case by strengthening? Okay, so let's use Sadia as the example. She sees this experiment. She's doing research into other alternative theories that explain everything in quantum physics, but don't have a many worlds aspect. Okay, they're single universe. And she's trying to do that. She's up to this point, she hasn't come up with a good alternative theory. The fact that she hasn't come up with one doesn't mean one doesn't exist. It could mean that there isn't one. And that's why she will never actually be able to find it, because it just doesn't exist, because reality isn't that way. There actually is multiple universes out there. Then she'll never come up with a good alternative theory. But there's no way for us to know that for sure. We've now corroborated many worlds by actually entering an alternate universe that we can go observe. There's no way Sadia doesn't kill her research program at that point. This is what corroborations really do, is they make it harder to come up with alternatives. So there's still cases of refutations. It's just that the refutation may not be an actual existing theory. It may be in its nascent research program state. As you start to get corroborations, as you start to have, I stress tested this theory and this happened, it starts to close down alternatives. This is what corroboration does, is it strengthens a theory by killing either real alternatives, if it's a crucial test, or alternatives that we're working on, alternatives that at this point are maybe not even legitimate theories, they're just ad hoc theories. And this is what an actual strengthening of a theory is. And this explains what corroboration is, why it's an important part of Popper's epistemology, why you cannot do without it, and why testing is so dang important to science. So the language of support should not be downplayed by Popperians, but needs to be understood in a refutational context, because it always takes a refutational context in Popper's theory. And that is the right way to think of it. And that's why Bayesians are wrong. The fact that Bayesians haven't figured out that positive evidence is actually negative evidence for nascent theories is one of the many things that Bayesian epistemologists have gotten wrong, and why their theory can't produce good results and never will. They are wrong about their theory. Okay, Penrose's challenge to Popper. Now, I mentioned part of this already, that when Penrose uses his supersymmetry and superpartners example to disprove Popper's epistemology, he's mistaking that it's not the demarcation between science and non-science, it's actually the demarcation between empirical and non-empirical. If he had understood that, he probably wouldn't have used that example. Let's now address Sean Carroll's question, which is, but what if we actually do find it? Okay, let's say we build a large Hadron Collider, and we actually find superpartners at this point. Can you really say that theory is non-empirical? Well, it depends what you mean by empirical. It's still not empirical in the sense that we never had a test that was definitive. We just by chance happened to find it. Okay. Okay, what's the status of the theories though? So now consider that the two competing theories are, on the one hand, regular physics, let's say the Standard Model, because that's the model that talks about particles.
Okay.
And its competitor is supersymmetry. So Standard Model without supersymmetry, and Standard Model with supersymmetry, or string theory with supersymmetry. The Standard Model doesn't say there aren't superpartners, so this doesn't refute the Standard Model. Okay, you could make that argument. And in fact, Andrew Crawshaw does make that argument to me. Okay. And he's a very good Popperian. He says, look, what you've done is you've produced a way to produce superpartners. And that's an important theoretical find. But you really haven't refuted the standard model any more than say you've refuted evolutionary theory. Evolutionary theory doesn't say if you have superpartners or not either. So if evolutionary theory doesn't say it and standard model doesn't say it, then clearly you haven't refuted it. And so you can't really say you've strengthened supersymmetry. Well, I don't agree. And let me just admit, he's making a good argument, so I'm not sure I agree with myself. and I could probably be persuaded otherwise. Let me make a case, though. His argument that the status of the standard model hasn't changed in the same sense the status that the evolutionary biological evolution hasn't changed because neither says anything about superpartners. That's actually a pretty good argument and gave me a little bit of pause. Here's what I would say about it, though. In real life, what would actually happen? We know what would happen is scientists would announce, we have found evidence for supersymmetry. It supports the theory of supersymmetry. It provides support for string theory because string theory was built on supersymmetry more strongly than, standard model doesn't have to have. Okay. So they would immediately announce that. Now, my point of view is that they're not wrong to, because I think there's actually a tacit refutation going on. Now, I just said there's no such thing as support unless it's tacitly actually a refutation of a competitor, although the competitor might be nascent. Now, Andrew says, no, that's not true. You have not supported the theory because there is no theory out there that you refuted. Okay, I'm going to make the case that there is. And here is what I think it is. In real life, not only would they announce that they now have evidence for string theory and supersymmetry theory, they would also announce an updated version of the standard model that now includes superpartners. Because the standard model is supposed to contain every single particle. So they have to update it all the time if they discover new particles. The standard model, by the way, is a kind of a weird theory in that most of it just comes by observation. They just go out and they test what's the weight of this, and then they put that in just based on empirical evidence. They don't derive it from first principles like they would wish. So it's generally saw as a fairly ugly theory by scientists, even though it's like one of our most important theories. Scientists hate it, right? It just inherently they know it's ugly and it's just the best we know how to do right now.
Okay.
So they update standard model all the time. Anytime something, if the God particle is found, then they have to go update the theory. Now, remember, when you update a theory, you're really refuting the old theory and you're creating a new one. Now, notice that we won't be announcing a new evolutionary theory based on the discovery of superpartners. So in my mind, the discovery of superpartners supports the theory of supersymmetry and string theory, depending on how you want to look at that, in that it tacitly refutes the existing standard model. Because part of even though the standard model didn't say there are no superpartners, it was kind of tacitly saying that based on the fact that the standard model was supposed to contain all the particles.
Right.
Which is why they have to then go update it. So they're going to treat it like a refutation because it is a refutation. And that's the sense in which it strengthens supersymmetry theory, is that now there won't be a non-supersymmetry version of standard model anymore. That's gone. They will have to come up with, here's how supersymmetry ties to the standard model, which, by the way, I think they've worked a lot of that out already. So in a sense, we've already refuted the original standard model, which is why this is kind of a weird example. But I think the idea of a tacit refutation makes sense to me. And I can kind of see why Andrew pushes back on me on that. And really, I'm going to throw that out there to the audience to form their own opinions now that they've got both opinions on that one. But I think something more is going on. That's why I have to look for the tacit refutations, because I think it is the case that finding superpartners supports supersymmetry theory. Therefore, as per Popper, something got refuted. I want to know what it is. I think it's the original standard model got refuted. I think it was a tacit refutation. Okay, so now based on what I just said, let's take the best theories without refuting the competition. Refutations are problems, but they're not definitive refutations. Popper, in Logic of Scientific Discovery, he points out that probabilistic theories are a problem for his theory, although he explains how to solve the problem. He says you can't really definitively refute a probabilistic theory. So he says, how do you handle that? Well, he gives this giant technical discussion that I didn't understand, and I don't think is even necessary for the most part for a layman like myself. Let's say you had a theory that the outcome could be A, B, or C, but instead it's always C. Yes, you can explain that as we happen to get C every single time. Well, do the experiment 100 times, do the experiment 1,000 times. If the theory that it can be A, B, or C is correct, and just by chance you keep getting C, that's not going to be repeatable. It will never become a basic statement. The theory that it has to always be C can't ever have a true basic statement. It won't be repeatable by a different group. It won't be repeatable if you do the experiment again. It won't be repeatable. I mean, it just won't happen, right? Because that's the way probability works. So the bottom line is that it never really ends up posing a problem for his theory. While in principle, if you take it too strictly, yes, it's a problem. In practice, it just never does, even when it's probabilistic like this. So now, based on that, let's take the two examples I came down to. A man is murdered and his wife has a motive. So why do the police go to the wife first and start to investigate her first? Well, it's because that's their best theory. They haven't really refuted an alternative theory at this point. What they've really done is they have, let's say, a basic statement, something like a basic statement. I don't know if this would technically be a basic statement, that this wife has a motive and they don't know of anyone else that has a motive yet. Well, that's good enough. That is enough to make the other theories problematic. Remember, refutations aren't definitive. They're problems, and we don't know how to solve them yet. The other theories have problems that we don't know how to solve. So it makes sense that the first thing we're going to go do is we're going to try to take the theory that the wife committed the murder, and we're going to try to make that a stronger empirical theory. Okay? We're going to try to strengthen the theory by making it more empirical. So we're going to try to figure out, was she there? Does she have an alibi? And during that process, we may end up refuting the theory that she committed the murder, in which case we will be then forced to go to the alternative theories that somebody else did and try to figure out who it is and figure out, did we miss somebody else having a motive? Okay. Nothing about this is actually at odds with Popper's theory. It's really just being too strict about the idea of a refutation. You have to understand refutation in the idiosyncratic way that he meant that term. If you ever understand it in a different way, then yes, Popper's theory doesn't make sense anymore. And then the DNA example was that we're trying to figure out if so-and-so is a descendant, Thomas Jefferson. In real life, we had the case of Thomas Jefferson where we wanted to know if he had a child by his slave. Because, of course, in our day and age, we want to know if he's a hero or a villain, right? So they do a DNA test and they discover that there's a certain marker that the descendants of the slave have that Thomas Jefferson also has, and it's rare. Okay, I'm making up that it's 1 in 10,000 chance otherwise. Okay, this doesn't really definitively refute the idea that it doesn't. There's nothing definitive here, right? We haven't demonstrated it is Thomas Jefferson's child. We haven't even refuted the alternative, right? I mean, it could be that his brother lived there. In this case, I think his brother did live there, but let's say the brother didn't live there. That's too obvious a case. Maybe the brother came by and on a chance encounter had a child with his slave. Maybe somebody else that was unrelated to Thomas Jefferson. So obviously we haven't really refuted the competitors. What we've done is we've made a problem for them. Okay. At this point in time, our best theory is that it's his child, right? That's our best theory, but it's just a best theory. The other competing theories, they're problematic. They're maybe even bigly problematic. Okay, but you could see how you might save them if you could demonstrate, well, actually, he did have a brother and they lived together. Or there's ways you could go about, therefore, resolving that problem, which would then make the competitors better again. Okay, again, this fits perfectly into Popper's epistemology. There's not a slightest ounce of problem here. Insofar as it seemed like there was a problem, it was really just because we were understanding the word refutation as definitive, when really we should be talking about it as a counterexample or a problem, because that's really what they are. It's the problem that's objective, not the definitive refutation that's objective. Okay, that's it. I've now resolved all the problems with Popper's epistemology that I originally raised. It turns out all of them boiled down to you simply misunderstood Popper's epistemology.